From the moment humanity first gazed upon the stars, a profound question has lingered in our hearts. Are we the only intelligent beings in the cosmos? Is this boundless darkness our solitary silent theater? For decades, the scientific community has maintained a cautious pessimism. This is the famous Fermi paradox. It succinctly highlights an existential contradiction. The scale and age of the universe seem to suggest life should be ubiquitous, yet we find no conclusive evidence of it. This clash between theory and observation compels reflection. Scientific inquiry must rest on verifiable foundations. Thus, mainstream scientific institutions adhere to a golden rule. Extraordinary claims require extraordinary evidence. Until compelling evidence emerges, we must assume the cosmos is a silent wilderness, and we are its sole watchers. This assumption stems not from stubbornness, but from scientific rigor. Yet this principle also raises a deeper question. When the evidence finally arrives, will we be prepared? Do we possess the wisdom and courage to recognize it, even when it challenges our entire cognitive framework? Our current cosmic picture rests largely on conjecture. Shockingly, over 99% of the universe's composition remains invisible to us. This is dark matter and dark energy. They govern the structure and destiny of the cosmos. The ordinary matter we recognize constitutes only an insignificant fraction. This means we are like infants observing the ocean, perceiving only the shimmering surface waves, while remaining utterly unaware of the immense currents beneath the deep. The tools we use to explore the cosmos remain primitive. Our theoretical frameworks may offer only a glimpse through a tube. Against this backdrop, a tiny speck of light entered our field of vision. It was formally designated 3I Atlantis. The 3I signifies it as the third interstellar object discovered by humanity. Atlantis imbues it with a touch of mystery and legend. Its discovery originated from the Pan-STA RS telescope in Hawaii, a system dedicated to sky surveys, aimed at discovering and tracking celestial bodies approaching Earth. Initially in the observational data, it appeared merely as an extremely faint speck of light, moving at an unusually rapid pace. Preliminary calculations of its orbital elements revealed it was not a native inhabitant of the solar system orbiting the Sun, but a distant visitor from interstellar space. Its velocity reached 30-5 miles per second, far exceeding the escape velocity of any object within our solar system. This unequivocally indicated it was an interstellar comet or asteroid, similar to our first interstellar visitor, Oumuamua. But after the controversy surrounding Oumuamua, the scientific community had grown more cautious. Astronomers swiftly mobilized global observational resources. From NASA's Jet Propulsion Laboratory to the Harvard Smithsonian Center for Astrophysics, extensive computational modeling and simulations followed, aimed at precisely mapping its trajectory and physical properties. During the initial weeks, it behaved like a typical interstellar traveler, traversing a clear hyperbolic orbit, strictly adhering to Newtonian gravitational predictions. Its brightness varied smoothly, showing no obvious signs of cometary activity, suggesting it might be an inert body composed of rock or meteor. Yet subtle anomalies began to emerge. Its spectral reflectivity was unusually high, exceeding the typical range of comets or asteroids. Its rotation pattern also appeared excessively regular, lacking the chaotic tumbling common among small bodies. These characteristics set it apart from all previously known interstellar objects. Initially, these anomalies were attributed to observational errors or its unique composition. Perhaps its surface was coated with special reflective materials. Perhaps its structure was exceptionally robust. Yet, it was precisely these initially overlooked subtle clues that laid the groundwork for a later, groundbreaking discovery. At the time, no one could have foreseen what stormed the seemingly ordinary interstellar visitor. was about to unleash upon the scientific community. It glided silently across the sky, like a mute messenger, carrying secrets from distant worlds, slowly approaching us, while we remained utterly unaware, still immersed in our inherent perception of a silent universe. Routine monitoring of interstellar visitor 3I Atlantis had continued for months, its trajectory traced a precise mathematical curve, completely within scientists' predictive models. Observatories worldwide took turns observing according to a predetermined schedule, recording its stable luminosity and spectral data. Yet at 3:47 UTC, a moment of calm, this predictable norm was shattered. A large optical telescope at the European Southern Observatory in Chile first detected a minute anomaly in orbital parameters. The automated computer system flagged it as a level 3 error, typically indicating atmospheric disturbance or brief equipment vibration. Yet moments later, the Deep Space Network antenna at Goldstone, USA, revealed identical deviations in its precise radar-ranging data. Within minutes, multiple observatories at different longitudes worldwide, including Japan's Subaru telescope and China's FAST Sky II, began issuing alerts in their data streams. All evidence pointed to one astonishing truth: 3I Atlantis was deviating from its predetermined orbit. Its deviation was not a sudden jump or abrupt turn, but an extremely smooth and continuous attitude adjustment, as if a giant vessel were executing an elegant turn on calm seas. The entire process showed no signs of explosions or collisions. No energy release was detected in either visible or infrared bands. Its movement was disturbingly quiet, as if the cosmos itself had parted to make way. Scientists' first response was to verify data consistency. They swiftly assembled an emergency verification team, cross-referencing independent data from diverse technical methods. Radiotelemetry data perfectly aligned with optical positioning data. Doppler shift analysis of radar reflection signals confirmed the altered velocity vector. All redundant observation systems reached identical conclusions, ruling out any possibility of local malfunction or human error. This was a genuine physical event. Subsequently, the global astronomical network entered heightened alert status, seeking to identify the external force causing this deflection. The primary suspect was gravitational perturbation. Had an unknown, dark minor celestial body happened to pass nearby, exerting gravitational influence, yet emergency scans of the surrounding space yielded nothing. That region was as clean as a vacuum. Calculations indicated that an object at least the mass of the Moon would need to pass extremely close to produce an observable effect. Such an object could never remain hidden within our observation network. Another possibility was an internal ejection of material, similar to the faint thrust generated by comets expelling dascent dust. This mechanism is known as the rocket effect or an on-gravitational effect. Yet the infrared eyes of the most sensitive Spitzer Space Telescope detected no signs of temperature increase or dust clouds. Spectral analysis also failed to find signatures of water vapor, methane, or carbon dioxide emissions. Its surface remained cold and stable. Solar radiation pressure was also considered, but calculations quickly showed the feeble thrust of photons, for an object potentially weighing billions of tons, was utterly insignificant, completely incapable of explaining the observed acceleration. After ruling out all known natural forces, the control room fell into a perplexed silence. Scientists looked at each other, faced with a flawless set of data and a physically impossible phenomenon. The deflection was precisely measured at 0.0 degrees off the expected path. This figure is negligible in everyday life, but on an interstellar scale measured in astronomical units, it meant its position would deviate by thousands of kilometers within hours. It was like watching a bullet fired from a barrel that, after traveling a kilometer, actually bent its trajectory mid-flight to precisely evade a speck of dust. Celestial bodies in the cosmos should not move this way, unless some form of intelligent intervention is at play, or physics entirely unknown to us exists. Meticulous analysis of pre- and post-maneuver date revealed even more astonishing details. Its velocity curve exhibited a perfect S-shape, a classic progressive acceleration and deceleration process, indicating the propulsive force was gradually applied and precisely controlled, rather than resulting from a single impact or explosion. This level of control far surpasses any known natural process, yet perfectly matches the propulsion characteristics of artificial spacecraft. Furthermore, when analysts retrieved electromagnetic spectrum data before and after the maneuver, they detected a brief magnetic flux peak. A powerful low-frequency electromagnetic wave radiated outward from the object's center, temporarily disrupting the motion of nearby solar wind particles. This pulse was not chaotic, but exhibited a peculiar symmetry in its waveform, suggesting the potential existence of a directed energy release mechanism. This discovery fundamentally altered the nature of the event. It was no longer merely an orbital anomaly, but an active operation accompanied by observable energy release. As these analytical reports were compiled and submitted to agency heads, the scientific community's conservative stance began to shift. NASA internally used the phrase anomalous self-propulsion for the first time, though the document was swiftly classified as internal reference material. A leaked copy had already sent shockwaves to academic circles. The term self-propelled carries profound implications. It signifies motion originating from within the object. It implies some form of mechanism or system has been activated. It suggests this interstellar visitor might not be a lifeless rock. That night became unbearably long. In the memories of many astronomers, they witnessed the possible end of an era and the quiet dawn of another. The universe's silence may never have truly existed. Only now have we learned to hear its whisper. This time it speaks. With an elegant, resolute turn, it delivers a silent proclamation to all observers.